Warm welcome, everybody, and thank you very much for joining today's session. My name is Karo Isipka. I'm the CEO of iPercept and one of the people who spent a decade on the question of how to digitalize CNC machines without slowing or breaking the operations around them. Before we begin, a few quick notes. The webinar is going to be recorded and we will send up a follow-up email with the content. Please do write your questions as they are coming up and they will be answered at the end of the session. In the next 25 minutes, I will walk you through why most CNC digitalization attempts stall and what has changed to remove that wall, what a fast and simple deployment actually looks like, step by step, and where to start when you are ready. So let's get started. And first, let me give you some context where we are in the series of webinars. We already had 3 webinars. Today is the 4th. In the first episode, we covered the paradigm shift from vibration analysis to motion analysis. In episode 2, Lillian, our head of product, went deeper into the motion pattern method and how one device reads the whole machine. Then in episode 3, Theodoros, our domain expert, walked through the subsystems and failure modes we actually detect. 3 episodes more positioned for theory, and today is a practical follow-up. That how does this actually land in a plant? If you have not seen the previous sessions, they are all available on our YouTube channel, but today's session is really meant to be self-standing, so you can watch the rest of the episodes later. So what we will cover today in 4 parts. First, why your last digitalization attempt probably stalled, and it is almost never due to budget. Second, what has changed in how we are approaching CNC monitoring and why that wall is now down. Third, what fast and painless deployment actually looks like, step by step with real cases. And 4, where to start, which machine to pick first. So let me start with the wall. Think about the most important CNC machine on your shop floor right now. Now you think about the last time someone proposed that it would be highly beneficial to have live data and facts about the health of the machine itself or the process itself. How far did you actually get that proposal? Most answers are not very far. And it's not because anybody is not doing a good job. And it's not because the budget was missing. The proposals tell because of 3 walls. And these walls are really stacked up on the top of each other. The first wall is the IT pillar. Every CNC monitoring solution comes with the same conversation: network change requests, firewall exceptions, complex cabling retrofits. Adding a new device class to a planned network at least takes 6 to 18 months IT project, and most IT teams are already buried. The second wall is the controller pillar. Some solutions pull data from the CNC controller directly, and that sounds clean at first. Then you find out you need a license from the controller vendor. You need to manage the variety of the different controller types. The OEM has to sign off, and some qualified machines would need recertification, or simply it means an unacceptable cybersecurity threat for the factory. What that means is at least weeks, but much more months of paperwork. The third wall is the thresholds or configuration pillar. And this is the one most people do not really see coming until they have already tried. Traditional monitoring solutions need thresholds. Someone has to define what normal looks like for each subsystem and each machine. And that means to find a perfect baseline. And adjustment every time is needed when you change a tool, fixture, or you change a program. And after all that effort, the system tells you something is wrong. It cannot really dig to the details of exactly what. Stack these 3 walls on the top of each other and we have the answer. Less than 1% of the global CNC fleet has any form of machine or process health monitoring today. And it is not because nobody wants it. So what changed? What is the rest of this session really about? And the question is that what if the sensor, the data acquisitioning did not need any of this complexity? So the same three walls could be flipped. First, IT. What if the sensor was not on your network at all? If you could use a separate network, possibly bundled to a 4G router, and the device wouldn't require factory network access. Second, the controller. What if the sensor did not talk to the controller at all? And it would be able to read the machine motion directly, and only that. No license, no OEM sign-off, no warranty drama. And then thresholds. What if you did not need thresholds and configuration at all? Absolute degradation estimation from day one, no baseline period, no threshold tuning, no retraining when you change a tool. Everything is in the background and automated. These were the design principles for us. And now I would like to show you how it works in practice. A CNC machine is a chain. The base sits on the floor, and above the base there are the axes, above that other axis, and so on, all the way up to the table. This is what we call the kinematic chain, and every component contributes to how the machine moves. So when component starts to degrade, a bearing in the ball screw, error in the linear guide, imbalance in the spindle, that degradation impacts the motion of the machine. Not the sound, not the heat, the motion. Now imagine that you put a sensor at the top of this chain, and you will see high sensitivity motion, and through that everything below it. This is the motion pattern method. One highly sensitive motion sensor covering the whole complex mechanics of a machine. And this is also what makes the motion pattern method machine brand agnostic. The kinematic principle is universal. Mazak, Dawson, DMG Mori, we do not need to know the brand to read the motion. And here are some of the machine brands already being monitored through the motion pattern method. Old machines, new, one-off, special purpose, or standard ones. The method works across all of them. And currently, we are monitoring over 50 plus different machine brands. And it really doesn't matter what will be the next machine brand, only that it has spindles, linear axis, and rotary axis in any combination. Now, at this point in every digitalization conversation, there are three questions which are coming up. First, do I need to call the controller OEM? In the old world, yes, and license or sign off needed. With motion pattern method, no. Second, do I need to open an IT project? In the old world, yes, network change, security review. With us, no. IT quickly reviews and accepts our straightforward documentation, proving that there is a decoupling from the IT infrastructure. Third, how long does my machine go offline? Old world, days of retrofit and the project. With us, a couple of hours. And so this is how, with the momentum, deployments can progress fast. So let me really show you that how a fast and painless deployment actually looks like. Starting with a 1 hour kickoff meeting, when the machine is confirmed with the deployment, including the brand, the model, the year, the type of controller for a G-code template, the device positioning is clarified, and the coverage of the external network and its parameters are discussed, and setting up the installation date. What is not required is to scope a complex integration project, to describe and design a sophisticated customer model, or start with IT and network discovery. Then phase two, the hardware. Everything you need arrives in a box: the smart IoT device, the 4G router, the power supply unit, torque screwdriver, a drilling plate to help to do the deployment fast. And that's it. You open the box and the technicians installs it based on very simple guidelines. On-site work, one person, 1 hour per machine, plus the removal of the cover of the machine. Step one, locate the position, use the drilling plate to mark where the device sits. Step two, mount it. There are two options depending on the machine: either bolt directly or use an adapter plate, bolt it to the adapter plate, and then glue the adapter plate to the machine. Step 3, wire to connect the device to its power supply. And then step 4, to power up the device and then covering the machine. The device boots and everything sets up itself automatically after it. Then the phase 3, to go live. And then a simple 5 minutes G-code test cycle is being run on every machine, which is composed of parts of the test where every single subsystem of the machine is moving individually and in a synchronized fashion, such as the spindle, which runs across different speeds, covering almost of its full of the working range, then a circular test engaging two linear feed drives, at the same time clockwise, counterclockwise, a linear test moving back and forth, or a rotary test, the same for rotary feed drives. The whole test usually takes around 5 till 10 minutes, also depending on the size of the machine. And importantly, the customer can receive templates and help in writing the underlying G code, which is really simple. And then the technicians run the test, or it's automatically set up that after a certain amount of workpieces, the machine runs the test by itself. And our device automatically identifies these test cycles. There is no trigger signal needed from the controller and records during these test cycles. And from here, the workflow runs by itself. The smart IoT device collects the motion data, the router takes care of the connectivity, the analysis runs in the background, and then the actionable insights come back through our customer portal, integrated to your choice of IT platform, or in the form of notifications, emails, or SMSs. Now, importantly, what the customer does not need to do during any of this is to tune anything, to do identification and setting of complex thresholds, defining complex detection rules, or train models on their own equipment. None of this is needed. The system self-configures itself. And then phase 4, to receive the first insights. Typically after 10 test cycles that are used to filter out external noise or auxiliary systems and focus on the details which matter, the first insights arrive, typically within the first week. What you are looking at here is an actual image of the portal, which is an optional customer screen with machine summary, health status across subsystems, and trends over time. The real actionability is really being born on component level, from which these test cycles, our system is able to identify on an absolute level the current health state of every subsystem, and then digging down to the component level, that within these subsystems, where are the critical component level issues, such as on this example, y-axis critical degradation with the ball screw nut and a belt drive system at the same time with the particular corresponding commendations. So the four phases. Phase 1, kickoff, 1 hour meeting, hardware deployment with a single person without long machine downtime. Phase 3, run the G code and the test cycle, and then access the first insights as soon as the 10 tests are being run, typically after 3 days or a week. And then the total customer effort across all phases is typically less than a working day, while from the hardware deployment to the first insights, there is 1 week time, and typically in between a kickoff and the hardware deployment, there are 2 weeks. So the 3 walls, they are all gone. No IT, no controller, no complex integration project. So with that in mind, where should we actually start? And this is a question what we commonly receive. And our recommendation is to pick the first machines where you want to deploy based on the expected payback, so that there is a fast economic payback corresponding to the choice of machine. And this typically falls back to 6 different options. The first one are drama machines, the machines what everybody knows about in a factory, and they produce a really visible win where everybody is really watching. Then the second is before and after comparison after a planned action, where a machine is due for renovation, and then you can really see if the renovation has been implemented completely and properly. The third, twin machines with different lives, where you would like to identify the performance and the health state of comparing these two machines with each other, as well as sometimes even more importantly over time. Then the next one is around the maintenance window, where the machine is due for overhaul, and then pre-check. That's really necessary. And the issue is so important that you couldn't push it until a maintenance window further down the line. Then for brand new machines, this is where the big collisions happen and the misunderstandings around what is warranty and what is not warranty. So starting up on a new machine can really help to organize relationship between end user and machine supplier based on data and facts. And that also relates to the sixth one, to machines which are close to the end of the warranty, to help this conversation. And then after picking the first machine, how does it look like to scale up the system? And here we see a typical case how a user runs our system from a technical evaluation on 5 machines to factory rollout within 12 to 18 months. Day one, starting with 5 machines, deployed in a single day. Within a week, component level insights are flagged. Within a month, there is an action corresponding to these insights, and there is a clear payback in economic terms. And then the deployment continues to more machines. And after a year across use cases, repeatedly showing the 10x ROI to be reached with our system. And then expanding to dozens of machines over 1 year and starting the expansion to further factories of the same company. And that is a typical success story, which is driven by missionaries actively engaged in CNC machine digitalization. Now, I would like to take an opportunity to show you 3 customer success cases. I'm just going to briefly show them for you. But if you're watching this as a recorded video, you can stop and really read through the whole customer story. We will not have time for deep dive in each cases, but these are typical success stories with our system. Furthermore, you can look at previous webinar sessions, such as the deep dive into the motion pattern method and monitoring complex machines, where we are showing you further use cases. What we see here is a change in the degradation score provided by our system over a period of time, monitoring specifically the degradation of a spindle and identifying a sudden degradation, as well as the impact of a properly carried out maintenance action, which allowed to reduce the expected downtime of the machine by 2 to 3 weeks, yielding 100,000 euros saving. Or another case with the lifetime extension of an axis, so that the axis, instead of the machine being completely renovated with a major, really expensive renovation, could be improved, and then the machine operated for an extended period of time in an absolutely stable health condition. And then a linear axis replacement, where a critical condition was identified and the impact of the right renovation was also demonstrated, saving, again, long days of downtime on the critical equipment. And so if you would like to see how the system works and you have a couple of machines in mind where you would like to start, don't hesitate to book a 30 minutes discovery call with us. You can easily do that through reaching out to us through our web page. And with that, I would like to sum up the webinar for today, where we discussed that why most of the CNC machine digitalizations projects stall, what changed since years ago with the motion pattern method, and how did that break down the previous walls. How does the fast and simple really work thanks to the motion pattern method, and where to start your journey. And with that, I would like to thank you for your attention on the fourth episode of the series of our webinars, where the next webinar is going to focus much more on the process and the process health.